Flack math! Give me some math and I'll give you some flack. Flack math!
All right. Here we go. We're doing lesson 45. We're going to talk about volume. Somebody want to give me a good definition of volume? Emerson.
Like something might be really loud, like not loud.
Yeah.
I was gonna say that. The thing that you turn up when listening to music. Yeah.
All right. Okay. So in math and geometry, what does volume mean?
Same thing about vectors, the area and size.
Okay, but see what word you used?
Area.
I know what you mean.
The stuff.
So here's a better geometric word for that, is space inside. The space is in geometry, space is three-dimensional. Okay? Area is two-dimensional. So when I say, do you see that area of the room over there? Well, that's not really technically correct, unless I'm just talking about the ground of the room. But that area is not a right way to say that. I would say that's space over there in the room. Okay? So space, we all live in space right now. We don't live in outer space. Some of you kind of live in outer space. But we don't live in outer space, but we all live in space. There's only one space. There's only one space.
Yep.
Okay? In this universe. And it's, or it might be, I don't know, maybe there's more universes or whatever.
That's not good.
Yeah, but there's just one space, guys. So volume is just the space inside of a particular object, okay? Now, I'm glad that you didn't say length times width times height. Now, that's how you calculate volume for a certain shape, but volume does not equal length times width times height for everything, right? All right, you guys paying attention? Are you playing with your calculators?
We're definitely not like the drug war game on the calculator.
Okay. All right, so put your calculators away for now. So area, let's review. Area is the size of a surface. Surface. Okay, so face is like the outside of an object. The face, it's two-dimensional. So how many squares fit in it? So when you calculate area, you're basically wanting to know how many squares fit inside of this two-dimensional space or two-dimensional area. Okay? So when you're talking about volume, volume has depth to it. So this is when you're saying how many cubes fit inside. Okay? So cubes are how many cubes, volume is how many cubes fit inside. Okay?
Okay.
So if I wanted to find the volume of this room, I would use a cubic unit. Like a good cubic unit may be a cubic foot. So what's a cubic foot? Describe to me what a cubic foot is.
Cube? The size of a foot.
Yeah. So if this is a foot.
That's not very sanitary.
That's not very sanitary, Mr. Flack.
Okay, so if this would be a cubic foot.
I'll say good job.
Okay, this is 1 cubic foot.
That's not a foot though.
Yes, it is. The size of his foot. You literally defines what a foot was.
Hey, you know what? You're right, Xavier. If this is not a foot, this is a cubic foot. Big difference. A foot.
That is not a foot because you use your feet as a.
Oh, so it's
Well, I wear size 12.
No, your feet.
I wear size 12, so my foot is a foot long. You know why they call it a foot?
Did you measure it against your? Mr. Flack.
Yes.
Did you measure your foot against a foot long?
Like a foot long hot dog?
No, foot long Subway sandwich.
Oh, I will next time I go to Subway. Okay, that's a great idea. Okay, here's a good trivia question. Okay, maybe I asked you this last year, but So think about a gallon of milk,
Yes.
not a carton. Like carton is like a half gallon, right?
No.
A gallon of milk is like a jug, right? How many gallons of milk do you think will fit inside of this box?
2.
7.
12.
3. I think
So-
3 or 4.
Well, a gallon for each
No.
side.
Yeah, I think 3. 3.
Yes, I said it first, by the way.
I actually said first.
Did you know this, Henry?
No.
The answer is in between 7 and 8 gallons will fit
No,
inside.
that's
it.
gallon.
That's crazy.
Yeah,
It
because
doesn't seem like
I
that
wouldn't
much to
guess
fit
that.
inside.
each side, each gallon fits one side. So. A gallon of milk is
One
something.
side,
It's not like that.
Okay,
gallon per foot.
So guys, so think about these cubic feet. How can I just, instead of going to get a bunch of boxes,
6.
how can you calculate how many cubic feet will fit in this room? How many of these boxes do you think will fit in this room?
297.
27.
Area.
So what do you have to do to figure that out?
Measure it.
Okay, what are you measuring?
Number.
The room.
Okay, so you measure this distance.
Yeah.
That's not gonna tell you, but this and this will tell you how many cubes you can put on the floor, right?
Now you gotta go.
If you multiply this times this, okay, and then you can put layers on top of each other to calculate how many layers you go on top. That's the height of the room. So that's why we multiply length times width times height. But volume is area of base
6.5.
times height. That's all volume is. Now, for what we're doing, we're not going to be doing anything too crazy, but we just have to find the volume by finding the area of the base. So in this situation, this is almost a rectangle, but it's not really, because this kind of goes in a little bit there, right? And then if we want, this is in a way, but if we took this out, there'd be like a rectangle, and then this goes in, and this goes in. Or we could take this whole thing out, I guess.
Or we could just put a wall over it.
You could put a wall over it. But this is what this room looks like. It looks like this. It's
You missed something.
That's not
You
right.
missed something.
Mr. Flack, you missed something.
What?
You missed that corner.
That's free problem set.
I said.
So this is kind of what the room
Mr.
looks
Flack, you're doing
like.
it wrong.
Oh, right there?
There's 2 in there like that.
Okay, got it.
So I gotta figure out that.
No, you don't.
Yeah,
That's
it's all on the board.
exactly how it works.
Yeah.
I corrected it on the board.
Yeah.
That's exactly how it works.
Yeah.
Oh, I didn't see that.
Well, you must be blind.
Well, then I get a free problem
That's
set because you didn't see it.
So Xavier, was that a
It's
math
like right
mistake?
now. No, it's because you don't have expectations.
You didn't put that corner and that corner.
Yeah, but that's not a math mistake. That's just,
I corrected you on the board.
Xavier's trying so hard.
You said at the,
Yeah.
you said.
you correct the math
school year.
mistake.
You said,
Ma'am,
I
sit
corrected.
down.
You're like
on the
standing
board.
up, like he's gonna fight.
That cube is exactly a foot. Problem set.
Yeah.
Ma'am, sit down.
All right. And then, hey, tell you what, if you catch another similar mistake like that this period, then I'll give you a free problem set. I promise. Okay. Look at
him.
Look it up in correspondence.
I'll be a lawyer. I'll get
Okay.
lawyer.
So to figure out how many boxes I can put in here, let's see, maybe this is 2 feet. That's like 2 feet there. And this is 2 feet. Or like 5 feet.
That's not 2 feet,
Maybe
that's 3.
that's like,
Hey guys, this is estimating, not.
yeah, we're just figuring it out here.
We're having fun.
Okay, and then let's say this is,
Well then, how many sheets of paper are in this thing?
okay, so do you think we have enough dimensions to figure this out?
What?
250.
I think so. What is this, 17 here? Because if that's 5 and 2, and that's 10, and that's 17. This is another 15 here, so I can do this. So will tell me how many boxes I can fit on the floor, right? If I take all that stuff
You
out.
messed up. You didn't even find us.
Mr. Flack, you did it wrong.
Oh no.
What did I do wrong?
No. Xavier, go.
Oh,
Oh.
too close.
This side total
is 17.
What
Yeah,
size
This,
total?
this side total.
Well, from here to here is just 15, but from here to here would be 17, but I'm just labeling it from here to here.
Whoa.
But good,
Right.
good
That was
job.
a close one.
All right, so what is that? 15 times 17, 225, 255 plus 20. So area equals 275.
Mr. Flack, you
Okay.
put 255 in the square. and
Oh
then
my
put
God.
275.
Whoa.
There's 255 in this area, and then in this part, you can fit 20 more boxes. Okay? So the total area of the floor,
Then somebody else
hey
got it.
guys, let's get through this. So the total area of the floor is 275. So this is weird. Hey guys, my turn to talk. Your turn will come Saturday. Okay? So I can fit 275 freaking boxes.
Hey, don't
On
use
the
that
floor.
word.
Son of a mother,
Okay.
let's go.
Calm down.
That's a lot of boxes. All right? Is that how many boxes I can fit in this room?
No,
No, why not?
because
Because
it's
that's
not
right.
Yeah, because look.
It's just the area.
What if this was 10 feet high? Then how many boxes could I fit in the room?
Why?
2,750.
Wouldn't it be 10?
That's
Well,
right.
box
You
for
just
every
multiply by 10. There's 10 rows of 275.
I said that.
So 10 times
What?
275. So volume equals 275, because that's the area of the base, times 10, which is 2750. That's awesome.
No, 2,700. Yeah, he said 27.
Okay, good job. Yep. If Xavier would have said that, he would have gotten 3 points.
Damn it.
Now he gets his half one taken away because he cussed. Bummer.
No.
On the internet.
Oh.
People have said worse on the internet.
Dude, now I have to put explicit.
Wait, what?
And when I fill out my YouTube info, I have to put explicit in the stuff.
Oh no.
No.
Way to go, Xavier.
You can edit it out.
He's gonna get demonetized.
I'm gonna get demonetized.
I'm just sitting.
Now you're costing me money.
His entire career.
Kids cost money.
4 cents.
Get with the program.
Now I might get 19 views instead of 20 views on this video.
I think he makes 4 cents.
Okay.
Not monetized.
All right, guys. So you guys get the basic idea, right? So the base can be any shape. As long as you can find the area of the base, all you have to do is multiply by the height and you're done. Okay? So let's do some examples. I'm going to erase all this. Let's do some examples, and then I'm going to let you guys work for the rest of the day. Yep, we're doing another one. We're just doing one lesson today. And then we'll do 3 next week instead of 4.
I'm gonna do 2 today and 2 tomorrow.
Well, we won't be here tomorrow. I'm not coming back.
Wait, what?
Yeah.
Maybe Tuesday.
He's bumping up.
All right, so
He's open you guys want to go for this school.
Uncalled for.
okay, guys. So here's what we're doing. When we talk about these things, we're talking about geometric solid. Geometric solids.
I didn't know we were in science.
Okay, solid is anything that takes up space. A geometric solid is anything that's measurable. Remember, geometric is the measurement of the earth. So geometric means I'm able to measure the solid. Yes.
What's something you wouldn't be able to do? Is that a
Like if I threw up on the floor right here,
I'm calling in for anonymous.
then that would be difficult to measure.
I mean, technically, that's
I
actually.
mean, if I threw up in a measuring cup, that would be easier for you guys.
If you were mad scientist, yeah, maybe you would
Mikey.
Technically, that's a liquid, not a solid.
It is, well, in science it's solid, but anything that takes up space is solid. Okay, so here's the deal. Geometric solids is a measurable solid, okay? And we sometimes call it a geosolid. The base of a solid
What'd you say about Jace?
is what we stack all the stuff on. Okay?
Why did Jace come back?
Base of a solid is what we stack on. So when we have stacks of boxes, this is the base, this is the floor of the room that we're putting boxes in. Okay? So when I say write geo-solid, so write geo-solid has the same base shape all the way up. Okay, do you guys know geometry?
Yeah.
What's the measurement of this angle here from the floor to the wall?
That's right angle.
That's a right, and it's also called a right angle, correct? A right angle, right?
It's called an upward angle.
So it's called a right angle. That's why we call this room a right geometric solid.
Do we know?
It exists.
Wait, we do? So
That's not. See, I'm a math teacher, so that joke isn't funny.
Oh.
Like, because I've heard it like 100,000 times, and it wasn't even funny the first time.
Oh, so Mr. Flack, can I tell you a joke? My friend was like, "That's the point," and I said, "That was a pointless point."
Okay, guys, what about a not right angle? That was so funny.
Okay, good job. All right, so
Is there
back
such
to
thing as a geo standard solid?
geo standard solid.
Geometric? Standard systems?
Huh. I don't know.
That's a very good point.
Okay,
Jeez.
if you were making a joke, I didn't get it. So a right geosolid is basically, it's the same base all the way up. So see how this floor, this shape of a floor, if there was nothing in here like cabinets or anything like that, this same shape would be the same shape as the ceiling. Like this weird looking thing that goes out like that, that's the same as the ceiling. Do you see that? The ceiling looks the same as the floor. And it's the same shape all the way up. So that's why all we have to do is find the area of the floor, the base, and then multiply by the height. Because it's that many levels of that same floor, that same shape, okay? So that's what a right geosolid is. Now, if you had something like this, this is not a right geosolid. This is not a right geosolid, because is that the same base all the way up? Well, it kind of looks like the same shape, but that shape gets smaller and smaller, doesn't it? So this is not right geosolid. What about this?
A pyramid.
Whoa. It's 4 triangles. No, this is the 3D triangle.
Three triangles is a pyramid.
And you ruined the joke.
Wait, where is it a cone?
Is this a right geosolid?
Yeah.
I have no idea. Yes.
Yeah, see how it's the same shape all the way up. So this is, thank you, a right geosolid. We just kind of shorten it to geosolid instead of geometric solid. Okay? So if it's possible, if you recognize that this is a right geosolid, to find the volume, you just have to find the area of the base. And so the base can be seen on the top, right? Because it's the same shape all the way up. So it doesn't matter if you look at the bottom or the top. If you can find the area of this base, then you multiply by the height and you got the volume. Okay? Yes. Well, this is actually called the base as well. So the base doesn't need to be visibly on the bottom. The base is the whole shape all the way up. So if I said bottom, then I'm talking about that. But the base is this shape, because that base is just the shape of the bottom. It's not the bottom necessarily. So for example, if I had an object like this, is this a right geosolid?
No.
Yeah.
Wait, but Mr. Flack, what if it's a dome ceiling
Oh,
on a square floor?
That's a good question. Doesn't work. That's not a right geosolid. It's got to be the same shape all the way up. You guys, let's focus.
I am.
So this is a right geosolid. You want to know why?
Why? Because there's more right angle.
Because this shape right here is considered the base. Because it doesn't have to go down to up. It's the same shape repeated a number of times. So this is the base that's repeated. So I could figure out the area of this base and then multiply it by now. This would be the height. Even though it's height in this case doesn't represent like how high it is. It's how deep it goes. So, but if you just took this and just put it on its side, then you could justify in your mind, okay, now it's the area of the base times the height, because the base looks like the bottom, even though that's not necessarily what the base is. It's not necessarily the bottom all the time. Okay? Yes.
but you're multiplying by height.
Right. So the height in this case is not how high it is. It's just the distance between the base and the ending base. So do you see that how I could just take this and stand it up? And then it would be a literal base and a literal height. But the height is not necessarily how high it is. It's the distance between the two extreme bases. Okay? But it's probably easier if you just visualize this standing up. Does that make more sense? You stand it up? Okay. So it's still the area of the base times the height. So let's do 2 examples and then we'll be done for the day, for the week. Okay?
I'm so glad we started on it.
Yeah, that is nice. It's a nice little teaser to the second
One
semester.
day and then you just go straight to the weekend.
Yeah.
Which school is actually like that?
Yeah,
My kids have 1 day a week.
yeah, you go like 5
Hey, guys, some students have to go 5 days a week.
Never.
You go 2 days a week.
I did that for about 5 years. And
5 days.
oh wait, I'm going 5 days a week.
Okay, so this is what your homework will look like. So this is what your homework is going to look like. You're going to have this, and then it's going to say, and then it's going to give you just a 2-dimensional version of what the base looks like. So this guy is going to look like this.
That's a Nintendo.
Okay, so you guys watching? You guys watching? This is
Yeah.
too. This is too wide to be in the
I'm
Nintendo.
actually watching.
You know what a Nintendo Switch is?
I'm paying attention.
Yes, the
Yeah.
Nintendo thing that's called Switch. It's a light switch. Nintendo.
So just so you know, I'm just so you know, I do play video games.
But you're a gamer.
So at home,
Name one
Go,
game.
Mr.
Okay,
Flack.
I play Call of Duty.
Yeah.
But
No.
my
Wait, which
favorite
one? Which
movie is my favorite game is Halo because I'm a naturalist. But here's the deal: I have an original Xbox. I have a 360. I have 2 360s.
I have a 360.
I have an Xbox One. I have a PS4. I have a Nintendo Switch, and I have a Nintendo Wii for
That's
older
the best
games.
console.
So-
Can I come over and play video games with you?
Mr. Flack, why are you
Yes.
flexing?
I am flexing. I am flexing a little bit. Okay, guys. So I just didn't want you to think that I was completely out of touch. So this is what your homework will look like. Does this make sense to you? This is not 2 different things going on. This is just the aerial view of this 3-dimensional right geometric solid. Okay, and then it's going to tell you what the height is. It's going to say the height is 4. So it's not going to say it like this, but that's pretty much what it means when it says the height of this prism or the height of this real right geometric solid. Okay? So how do you find the area of this? Somebody raise your hand and tell me how to find not the area, but the volume of this little thing here. Xavier.
Height times width
Big.
face.
Okay. So what numbers am I multiplying?
2, 6, and 4.
Okay, right. So basically, remember, volume is always area of base times height of the right geosolid. So the area of this base is a rectangle. How do you find the area of a rectangle?
You don't.
48.
Your answer for everything, when it's not dividing fractions.
Length times width, right? So that's 2 times 6. And then the height is 4. So yes, it's 48. So this is 48. Instead of square units, we're going to say cubic units. So if this was inches, it'd be cubic inches. If it was feet, it'd be cubic feet. Yes.
No, 2 times 6 times 6.
Oh, good catch there.
Drinks.
Wait, no.
I got both of you guys.
We
You
said
can't
at the
speak.
exact same time.
You should give me
I drinks the both.
I
Both.
We both did.
think Austin, because he said,
Yeah,
Mr. Flack, Mr. Flack.
I had my hand. I had my hand raised.
No.
I think that's more of a.
Yeah, I wasn't. You're interrupting.
That's good. I'm going to give you both a free problem set.
What?
Whoa, Xavier, relax.
Calm
Yeah,
down.
I wasn't paying attention.
Oh, Xavier.
Xavier is getting triggered.
You
Getting
could-
No.
Okay.
This is tyranny.
Okay, how we doing? Does this make sense?
No.
Okay, let's do one that may be a little bit more challenging.
It
but
doesn't
not
make
too bad.
sense because
Mr. Flack, that L is a sideways face.
That's no.
Okay, so this is what your next problem might look like.
Is it the swag problem?
There's no problem with swag, okay?
No. The problem is doing the swag.
Okay, so this is what the next problem might look like. So this is just the same shape, but this is an aerial view of this shape. Okay. So I have to give you the height, right? So let's say the height is 6 feet.
I do not sound like a water.
No, it doesn't.
You know what it sounds like? Is a distraction in math class. So cut it out.
I can't do it. I'm not making it.
If you want to know what a water drop sounds like, I'll do it for you later. But for now, let's do this. How do you find the volume of, nope. How do you find the volume of this shape?
you don't.
You do. That is the answer to some math questions, but not this one. So who can tell me how to do it? Austin,
The answer is 1,440.
is it?
Yeah.
Okay, well, tell me how you did it.
Okay, so I multiplied the base first.
So how do you find the base of this?
So 4 times 6 times 6.
So that would not be right. That's not how you find the area of that base. How do you find the area of this
Like cut
base?
it up or something.
You add
Yep,
them all
yes, you cut it up, then
4 times 10, then 5.
And then you do 4,
Like this.
no, 6 times 6, and then you divide by 2. The triangle,
yep, so this is a 6 by 6 triangle.
and then you have to divide by
Yep, so 6 times 6 divided by 2, which is 18, right?
2. Sure.
Okay, so what's the area of the base? I put 42. Is 42 right?
Yeah, yes.
Because that's 18. See how I got 18?
The answer is wrong.
Because 6 times 6 divided by 2, that's how you find the area of a triangle. And then this area of that rectangle, which is just 4 times 6, length times width. So 24 plus 18 is 42.
You don't.
So now what do? How do you find the volume? What do you do now?
Multiply 42 by 6.
Okay, so this is 6 feet. So 42 times 6 is going to be 252. And what's my unit?
Feet.
Number.
It's not feet.
Look at this.
It's cubic feet.
Cubic feet. Good job, Xavier. So you can put a little feet with a 3 exponent there. Cubic feet.
What?
Okay, do you guys think you can handle this? You can find the volume of 3-dimensional shapes? Geometric solids, right? Geometric solids? Okay, all right, good job.
Black math, give me some math and I'll give you some flack. Black math.